Okay, well, I guess I'll do questions now. Someone's asking, how did that megaton idea I mentioned on Twitter work out? I have not done it yet. It's a little bit scary, and it's not directly needed for what I'm doing right now. So it's something that'll happen later if it happens. I'll let you know. I will do a demo of this thing if I implement it, because it's kind of crazy in a good way. Do I have any reason to think my iterator system would not work with like some crazy tree with some specific access pattern? No, because like being able to visit every element of a data structure is a very basic property of a data structure. If you can't do that, then you're in trouble and you're not organizing your data very well. So you just write the iterator as the thing that visits all that stuff. For tree structures, it's very well known how you write iterators for those, right? It's kind of nuanced exactly, you know, because the amount of, you want to minimize the amount of state you save in the iterator, and that what you can get away with saving or not saving sort of depends on the structure of your tree. But it's well understood. I'm waving my hands in front of the camera a lot, meaninglessly. Someone's asking, I don't understand how SOAs are practical. Resizing SOAs means shifting tons of data around. The offsets between struct members can no longer be known at compile time. Both of those are false in different ways. How is resizing an SOA different from resizing a non-SOA, right? If you call realloc or something, that's probably a copy because you're probably not using the same memory back that you had. And if you are in the general case, then you've got tons of internal fragmentation. So you're copying anyway, whether it's SOA or AOS. So in general, what one does is designs data structures that don't need to copy when they expand. Part B, offsets between struct members can no longer be known at compile time. Yes, they can, given that you know the length of the array, right? If you know the length of the array, then you're fine, right? Now, for something like a bucket array here, right, you don't know how many items are in the whole array, but you know the size of each bucket. So if each bucket has 20 items, then it's a compile time computation what the offset is of each element. Someone's asking, is there a way to specify a specific different iterator, for example, iterate in reverse? I have not provided a way to do that yet. I'm not sure I want to go there, just because on the one hand, you want this for to be very versatile, right? Let me find a for. You want this to be a very versatile thing that people can use all the time. On the other hand, if you start making it crazy and complicated to accommodate a bunch of use cases that are rare, then it's maybe a net lose. So I would say that I have to see how things go in this particular language with these particular applications and just see what feels right. You can always drop back from this version to this version, right? And after you call iterator make, you could set some flag on it that says, actually, let's go backwards, right? But there's no syntax for saying like, you can't say like for backwards here, right? And the reason is just because forward or backward is relevant to a lot of things, but not everything, right? Like I said, a hash table is inherently unordered, right? A stream, if you're getting things from a network stream somehow, I mean, I hate to go all C++ and get totally abstract, but suppose you're reading stuff from a stream-like thing, maybe you're uncompressing data, and you don't have visibility into what's at the end of the data. that is inherently ordered, but it's inherently forward. Like you can't go backwards anyway. So a lot of these concepts are only really useful in a minority of cases. Now that said, just when I'm iterating over integer ranges, like for 0 to count -1 or whatever, I sometimes do find myself wanting to go backwards on these, but not that often. And then often, even when I did want to go backwards, a redesign 2 days later, suddenly I don't do that anymore. So I'm not really sure how worth accommodating it is, but we'll see. The same thing about multiple different iterators. There's not really a way to do that at this time with the for loop syntax, but you would drop back to this syntax. Which, by the way, this count was all user code, right? That's the actual syntax that you do, and then you put your own code in here. In the bucket struct, the Bitfield is an array of bools. Someone's asking this. We covered this last time, so I didn't go into it. It's just, I did that to be lazy right now. Right now, a bool is 8 bits, so I'm wasting memory in that occupied mask. But it's relatively straightforward to turn that into a Bitfield, and I just didn't want to complicate that. And the reason I haven't made a Bitfield user-level data structure to do this kind of thing is because I want to have the language have the idea of a 1-bit Boolean later on that you can just use, just like regular Booleans, as long as you're aware of the 1 or 2 extra caveats that come with bitwise manipulation. So I'm just leaving it that way for now because that's what I want the code to basically look like in the end. It's just that those bools are 8 bits each right now. Someone's asking, would allocating arrays at far apart fixed virtual addresses be beneficial so that they have room to expand without needing to be relocated? I've thought about that. And in fact, I've thought about that as a language feature. Like I've thought about having some kind of array that's like, this is a type of array that's going to be big and resized a lot. So, let me expand into my own address space, right? The thing about that is suddenly you're talking about taking up significant operating system resources. And even in a 64-bit address space, which I'm sort of assuming for most things here, you kind of have to treat that as a special case. You can't just do it willy-nilly, like, if I have this standard dynamic array like I use all over the place, let me go to bucket array. If I have like this thing do that automatically, then I'm probably eating a ton of pages or whatever, or this thing is lightweight enough that I want you to just be able to forget about it and not worry. But like if you leak one of these and it leaks that kind of operating system resource, you're in trouble, right? So I've thought about that. I've never really, it's sort of a new thing with 64-bit operating systems that you would be able to do that, and I just haven't ever done it in practical cases, so I don't know. I don't know how it works out. If somebody has, let me know. Have I thought about threads, concurrency, coroutines much yet? No, I haven't. Do I write iterator remove to support the remove keyword? I don't support it right now. And I'm not sure that I want to support it. Again, because remove doesn't really make sense in all contexts, or sometimes if data structures are complex enough, you need to specify how you would remove. So I just need to think about it. If we come up with a thing that makes sense, like here's a convention that makes sense for most use cases of how iterator remove works, and it would be very simple to to let you define it just like you've defined make and next, right? I still wouldn't require it, right? I wouldn't want to require you to define iterator remove just to make an iterator, just only if you wanted to use the remove keyword within a for loop. The more I think about it, the more it seems likely, actually. I just, because I wanted to get this first level of this functionality in, I just wanted to get these because this is the bare minimum. But I could see remove working, I guess. Is using always implemented via a pointer? No, using has nothing to do with data storage. In fact, you can go back on YouTube to the first time I demo that. You can using anything. You can even using a function call, right, which is actually more expensive than a pointer, but you can also using a value, which is less expensive than a pointer. It just depends on what you want to do. Have I thought about allowing filtering in the for iterator? I mean, there's two kinds of filtering, right? There's the kind where you just want to skip over some items, and there's the kind where you actually want to modify the collection, right? If you want to modify the collection, well, both of those you can already do pretty easily, right? Like the idea of having a filter kind of comes from Lisp, sort of, and some other languages have adopted that. But you can, like, if we implement, if we implement support with custom iterators for the remove keyword, you would just be able to say this. And you would do that under certain conditions, like if I want to filter it, remove it. So there would be no reason to introduce a keyword for that. For the kind of filter that's just like skip this element, you do the same thing, but you do here and you say continue, right? So both of those are trivial cases that I don't think warrant any special support at all. They're just, I think the idea of filter as being a separate thing from iteration just comes from a functional language mentality where you don't like to think of things happening in sequence. But here, if you just accept that this is happening in sequence, then it's fine. Just step one is this, and if you didn't filter, do that. This is how I program all the time. I don't find the need for a filter. Yeah, okay, so actually I forgot to cover this. Someone is saying, do the for loops now create an it variable and an iterator variable? For custom for loops that are like of a custom data structure like this, they're called by default it and iterator, right? If it's an array, if it was some array that was a built-in language array, this is still it and it index because it's not really an iterator, it's just an index. We might want to change it to be a similar name, but for now I wasn't sure enough about that, so I kept the names the same. And if it's just a range, you only get it, right? So whether or not, the idea right now is just to have that be context dependent. Whether or not it becomes confusing, we can change it. We have to see. This already confuses me sometimes because I think of this as an index sometimes, but it's really the subject. It's called it. So I don't know. All customizable. Will there be classes of iterators, e.g. random access bidirectional? No, that's up to you to decide. Now, if you wanted to implement that, because I don't, most of those classes of iterators don't make sense for most things that you want to do, and I don't see the point of specifying that stuff at a language level. Now, what you can do, you could wrap, so what did we have here? This was a for over table, right? Let's say, a hash table is a bad example for this because hash tables are inherently randomized. But let's say we wanted some custom iterator. Actually, this kind of answers my previous questions anyway, right? I can always wrap this in some polymorphic struct that just points at the table and just says custom iterator of table. Like custom iterator could return some other type that implements table that gives you a different iterator, right? So you could just say backwards iterator You could say backwards of table because backwards could be a polymorphic function, right? So this is how you would do it. If you wanted to go backwards, if you wanted to go in crazy order, whatever, you could do it. You could make it happen this way. I don't think that it's time to implement a custom syntax or even formalize that, because I don't, in C++, all that stuff just is in my mind as crazy complications that I almost never care about. And if I did care about it, I'd rather do it myself anyway. And that might just be my personal taste, but that's how I feel about all that. But yeah, you could do this. I don't know why I didn't think about this in response to the earlier question. Sometimes because all this stuff is really new, I just don't think about all the things that you could do. Someone's saying C++'s templates are slowing down compilations a ton. Are we going to see the same problems here? I believe not, but we'll see. There's several reasons why not. One is because we don't have a header file model. So we only ever process each of these polymorphic functions once for a given set of arguments. And then we store that. And we've got one global compilation unit. So we don't ever need to, when we've got something polymorphic like, let's look at an iterator routine, right? So iterator make is polymorphic and iterator next are polymorphic based on what kind of hash table, right? We'll only ever generate these once for each hash table. And if it's generated, the compiler is able to find the previous version very quickly. So that should fix that. Yeah, and I mean, the other thing that happens with templates is you end up doing header-only programming. You end up putting tons of stuff in headers in C++, and then you end up chewing through that multiple times to compile your code, and we don't have that problem either. So I don't foresee this as being slow. If anything is slow, it'll be this thing, this case where I'm overloading a polymorphic thing. If this is a function that I call a zillion times, then this might start to get expensive because I'm doing this. But that's even true not in the case of overloading. Like if I call this a zillion times, even if this is the only version of foo, I'm going to be running this modify code, right? So that's sort of something that I decided to do as the programmer. And I won't incur that slow, like foo existing will not slow me down. It's just if I call foo a trillion times, then it might. But I don't think that is necessarily going to happen. We'll see. If it does, there's actually ways of dealing with it. Like we could actually compile this to native code instead of running it in bytecode, right? We'll see. But that's the only thing that I even think could potentially be a speed problem here. And if it is, I think it'll be easy to take care of. Or it's not an open problem in computer science, how to take care of it. Let me put it that way. It would require elbow grease. Do I have any thoughts about the problem of maintaining a state machine being less efficient than all at once designed for iterating complex structures? You need to spend a lot of time updating where I am state and then doing a bunch of branches to figure that out. Well, if you mean keeping the state in the iterator versus on the core structure itself, you could do that. You could make an iterator that's mostly empty and just keeps its state on the core structure. The thing is then that you're sort of restricting yourself to only being able to iterate that thing with one thing at a time. And, I mean, it's redundant to say this, but also being not thread safe at that point. There's just, you're making that choice, but you can do that. Like the fact that there's an iterator doesn't mean that you have to put all the state in that iterator. You could put the state anywhere. They could be in global variables. It doesn't matter, right? It's just whatever your iterator next procedure decides to do. Now, it's good design usually to keep that state in the iterator if you can, because then you can iterate multiple times. You don't have to worry about other people iterating and whatever. But if you need to do something different, you can do something different. the iterator would just then stand as a placeholder for how to get to the data and call the right function. Someone's saying the iterator concept makes the looping less explicit due to possible side effects of iterators' hidden logic. Doesn't this conflict a bit with the overall design philosophy? I don't feel like it. Like, I feel like the design philosophy is finding a sweet spot between complexity and ease of use, right? And this is my attempt to aim for the sweet spot, right? Having written a ton of gameplay code over the past 10 years, as well as engine code, I find that when I have clean gameplay code, it's still doing all this iteration all the time. And if I can make iteration as easy and mindless as possible, I save myself a lot of work and a lot of friction. However, the implementation of that I want to be as simple as possible. So I don't want to do the C++ thing where you need to define a bunch of boilerplate, right? So this is the happy medium where you've got a couple of functions and it just works, right? And if you don't want to use that feature, you don't have to, right? You can always just do a regular for loop or a regular while loop. And in fact, if you wanted to make sure in your coding standard that nobody ever does that because you decide it's too complicated for your house coding style, then your compile time metaprogram can just search for that as it compiles and reject it. So I don't really see a problem there, right? It is more complicated to do this than to have a for loop that doesn't have this feature, but it felt to me like the right thing. But I don't know, maybe, in the long term, maybe we'll decide it's the wrong thing. Maybe we'll decide that somehow that is better implemented with a compile time metaprogram. I don't know. We'll see. Syntax for optimal could just be casting the iterator type. Yeah, so Tyler said, I guess he typed that before I said the thing, but yeah, you can do whatever iterator type you want just by changing the argument to 4. Dr. Jeet says, my main use case for multiple iterators in code is to iterate just the keys, just the values, or both of a hash table. Yeah, I mean, in my particular design here, I return the pointer to the hash slot for the hash table, I think. So I don't really care if it's not like I'm copying the values, right? Now, so unlike C++ actually as well, the main thing that you get in the loop is not really the iterator, it's the value, right? You don't tend to think about the iterator unless you want to, because remember, it's like for it, comma iterator, right? And you only get the iterator name if you ask for it. So anyway, oh, I guess I do return the value here. I return the pointer for the bucket array. Where's my... So pair is defined up here in the hash table now. So I do return the value a copy. I guess in this case I just wasn't that worried about it because I'm thinking about it as small values. But if they're big values, I could see wanting to do that. But yeah, you could say for values of table, blah blah blah, and you could just make values be a function that returns a thing that helps the for loop find the right iterator. It's it's a little bit of an extra wrapper around stuff that you would already do, but I don't know if that's more complicated than what you would get anyway if you built in custom support for that. I don't know. We'll see how things go going forward and whether that needs to change or not. Calling a templated function wrong with a lot of overloads generates a huge dump of all the candidates in C++. How does this language handle that? That's not really a problem that I've attacked directly, except that, and I've demoed this in previous sessions, when you're calling a polymorphic function here and you get an argument wrong, generally the output is a lot cleaner. It's not the really horrible, hard to read C++ dump mess, right? Now, whenever you're trying to design error messages in a compiler, there's a lot of, the way error messages get good is just by lavishing a lot of attention on what are the real errors that people run into in the world and how do you give them more information to solve their particular problem. And that just hasn't been done in this case yet because I just implemented the functionality. But I don't necessarily think it's that hard, but we'll see. You know, I mean, you could imagine, you could imagine having a case where if there's a lot of parameters and you match most of them, like two of these routines matched 5 out of 7 parameters, you could suggest those 2 as top matches and say which parameters missed and then list the rest just for completion, but just 1 line each with no fuzzy detail after that makes it hard to read. I don't know. We just have to see. I don't think of that as that hard of a problem. I think the reason it's terrible in C++ compilers right now is because C++ compiler writers have historically not given enough importance to good error messages. And they're getting better about it, though, recently. So I think you'll see that improve even in the C++ world. Yeah, remove is a keyword. It's just I haven't supported it yet in custom iterators, right? What do the errors look like if you don't implement the iterator correctly when using the for loop? I'll show you right now. It's honestly not that user-friendly yet. And it's, again, just because I haven't put time into it. Because I'm spending more of my time on actual. But say like I typo the iterator, whoops, let's not put a semicolon. But I typo the iterator next here, right? So the compiler's not going to find that. And let's see what it does. Let me clear the screen so that we, you know. Oh, well, in this case, this is not that friendly of an error message. It's finding the other one, right? There's only 2 iterator nexts in this whole program. It's finding the other one and saying like, this is for a table iterator, but we wanted a bucket array iterator, right? So in this case, you would just have to know that it's not finding your bucket array iterator, right? If there's another iterator next, let me just say, imagine there was one for an entity, and I don't know, it doesn't do anything, right? I'm just going to return null, false. I hope I didn't make a dumb mistake there. So now there's going to be multiple other iterators, which is what you would have in a real program. And now it just says, look, it doesn't match any of the possible overloads, right? So we have one in demo and one in bucket array. And this particular call doesn't match any. So then you're like, well, why doesn't it match? Well, you can figure out that, let's make this a subtler typo. Let's say I said iterator, I spelled iterator wrong, right? So at first glance, you might not see that typo. But you could say, wait, there's this one in bucket array is listed in this little list here, but this one is not. So you could narrow it down that way. But yeah, as to what can be done to make that even more user-friendly, we'll see over time. But it doesn't do some C++ thing of dumping you a giant molasses river of scary information. Someone's saying filter is surely less about things happening in sequence than reusing and composing filters. Right, but you can compose functions already. So if you want to compose filters, have some filtering functions and compose them, and it's fine. Who cares? Like, I don't think that has to be built into iteration. I think they're separate. Filter is a bit more useful when you have a lot of functions that consume iterators, e.g. add everything in this iterator to my collection, then you don't have the luxury of tossing in an if guard Yeah, but if you're building that kind of a system, I mean, why don't you just pass a parameter of like a function that says true or false about whether you want that item, right? Like, that's a very standard, that's again a very Lisp thing to do, for example. Like, I don't see why you need to make a separate kind of iterating to do that. You just pass, well, here's my iterator, and then here's a filter function that'll give you a yes or no for every item. Done. How do iterators cooperate with the SOA keyword? Someone is asking. They're orthogonal, basically. They have nothing to do with each other. Uh, the way SOA affects anything is the way it affects iterators. So, you know, if you've got a pointer to something, but the something is SOA by default, it'll be an SOA pointer, which will takes more memory because you have to describe the format of the array in the pointer. But aside from it, it just works, right? I haven't fully tested it, so there might be a couple bugs in the implementation yet, but those will get ironed out, right? Because they're orthogonal language features. They're supposed to just work always under all cases. Someone's saying the only thing they're missing so far in this language is something to make error handling less annoying than it is in C. It's called multiple return values. That's already in. Yeah, so James Woodman is saying about compile times, you can easily profile and know how much time is spent on baking and modify blocks. That's a very good point, which I should have thought to say, right? Now, that's true, but also at the same time, depending on how multi-threaded the compiler is being, it might be hard to profile, right? But you could always, at startup, maybe set some variables saying, okay, compiler, please be single-threaded for now, and don't do things in parallel because we're going to profile. And that'll result in a slower compile, but it'll tell us very clearly how much time we're spending doing all these things, right? Like I think in a final compiler that's very important. And so that'll give you much more visibility than you typically have in something like C++. By what process do I foresee changes being added to the language after it reaches 1.0? I'm just not thinking about that right now. Getting to 1.0 is my concern. We're going to get there, and then we'll decide what's after that later. Do these iterators handle stuff like inserting stuff into the structure while you're iterating through it? Or is it just like C++ where you don't do that? That's up to you. It's generally a little bit of a hairy thing to do correctly, right? So like if you're iterating a binary tree and something gets added, if it's added to the left of where you, say you're doing like a left to right depth first traversal, right? If it's added to the left of where you are, do you want to visit it or not, right? Or do you just want to make sure that it doesn't break your iterator and that you skip it? That's sort of an implementation dependent decision. What's the correct behavior? So you have to let the programmer sort of decide. So, you know, when you make an iterator, well, and you know, should the iterator get invalidated? That's another thing that can happen is like, you know, maybe the iterator panics your program because that's not supposed to happen. You're not supposed to modify the thing while you're iterating, and you want it to be a hard bug if it happens, right? These are all, you know, different choices that'll be made differently in different contexts. So I think the most that the language can do there is make it easy for you to do what you need to do. So when you call iterator make, right, one of the things that can do is tell the host structure that's being iterated, hey, here's another iterator, right? That host structure could keep an array of iterators or whatever. And then if the host structure is modified, it could invalidate the iterators, right? Or it could tell one particular iterator, oh, there's this item that you're missing that you need to come back and visit, although that then will result in a much heavier weight stateful iterator, right? It's up to you. I believe the current structure will let you do pretty much anything that you want in that department. But I don't know. Again, if there's something important that we're missing, we'll see what's the most clean way to add it. Okay. Someone's asking game reveal when. I think maybe next time. You know, I wanted to get some basics down and talk about a little bit in the way of new features. And then next time I'll probably be going over sort of an existing game that's in development and talk about, it'll sort of be a review of language features and maybe talk about how some of them have changed or been made more robust and how they're being used now. And that might be several demos worth of material for all I know. I mean, these always take longer than I expected. Like today's was an hour for the main demo, and I thought it was going to be like half an hour because I'm just demoing iterators and, you know, overloaded polymorphism. But apparently, I just talk forever given the chance. So it is what it is. All right, thanks for stopping by, everybody. I'm going to go home and be at home. I'm not sure, as always, when the next demo will be. I will do it when it makes sense. I'm going to take a little bit of a vacation next week, so it may be a few weeks. We'll see. Bye, everybody.